So dear students, in this video we are going to discuss about the different types of diffraction. So basically there are two types of diffractions. One is Fresnel's diffraction. Fresnel's, S is, we used to say Fresnel's, this S is silent. So Fresnel's diffraction. Other one is Fraunhofer diffraction. Fraunhofer diffraction. So we will see what is meant by the Fresnel diffraction and what is meant by the Fraunhofer diffraction. Okay. We are going to compare the Fresnel diffractions and also the Fraunhofer diffraction. Fresnel's diffraction, other one is say Fraunhofer diffraction. Okay. First of all, we should see what is meant by the diffraction. As we have discussed, diffraction is nothing but the mutual interference of secondary wavelets, or you can take penetration of light into the geometrical shadow of the obstacle, or you can say the bending of light around an obstacle. Okay. Actually, that what about the size of the obstacle and what about the wavelength? That means actually there is important point you should remember, that size of the slit where we have taken in the previously, that size of the slit should be, say d, it should be the order of the wavelength of the light. Okay. Okay, then you can say it is a good diffraction pattern. Anyway, that we'll see again in the next classes. But coming to here, what is meant by the Fresnel diffraction and what is meant by the Fraunhofer diffraction? So basically, as we have seen in the previously, for any diffraction, you need a source, then you need an obstacle, then you need a screen, right? So that means you need a source, then you need a obstacle, then you need a screen, SOS, right? So these three are very essential for any in order to observe the diffraction. So then coming to the Fresnel diffraction, say there is a source and there is a screen and there is a obstacle. So actually this source and the screen, they are at finite distance from the obstacle. So what I am trying to tell you, source and the screen, they are finite. They are finite from where? From the obstacle. Okay. From obstacle. Okay. As like we have seen in the previous video, there is an obstacle just like a slit, or it may be a knife edge, right? So from there is at a finite distance, source should be there, and there is at a finite distance, screen should be there. Then you say it is a Fresnel's diffraction, because the Fresnel is a person who observed this diffraction, that's why which is a Fresnel diffraction. Okay, so that means this can be represented as it is finite diffraction. Okay, or you can say near field diffraction. Near field diffraction. Near field diffraction. Whereas in the case of Fraunhofer diffraction, this source and the screen, they are infinite distance from the obstacle. Okay, that means source and the screen are infinite distance from the obstacle. Okay, then you can say it is Fraunhofer diffraction. Now there may be a question to people, sir, how about the source and screen are, if it is at the infinite distance from the obstacle, say infinite, right? So infinite, or you say the infinity. That means what? If it is at infinite distance or infinity distance, then will you go for infinity distance to put a screen, or will you go to infinity distance to put a source in order to get the diffraction? No, it is not in that way. But relatively, when compared to the Fresnel diffraction, this source distance and the screen distance from the obstacle is infinity. So in that way you have to compare. Okay. So for example, the source and screen distance in the case of Fresnel diffraction may be a limited distance of, say for example, say 1 meter or 2 meters, like that. Whereas if you compare that one in the case of Fraunhofer diffraction, this may be 1 kilometer or 10 kilometer in that way. Okay, then you say that relatively this is infinite distance from the from the Fresnel diffraction. So that's why we represent the source and the screen are infinite distance from the obstacle in the case of Fraunhofer diffraction. That's why we say this is a far field diffraction, which is a far field diffraction. So near field diffraction is called the Fresnel diffraction. Far field diffraction is called the Fraunhofer diffraction. Okay, now yes, good. If it is near field, then how about the source? As we said, source is a nearer, then the shape of the source will be either spherical or it may be a cylindrical. Okay, the shape of the source, it should be a spherical or it should be a cylindrical. Okay, why? Because we know if the source is near a distance means the wavefronts which are coming from the source which are having a shape which is like spherical. So the wavefronts which are spherical in the case of Fresnel diffraction, whereas in the case of far field diffraction, the wavefronts which are plane. So from this you can able to understand spherical wavefronts are used in the case of Fresnel diffraction, plane wavefronts are used in Fraunhofer diffraction. Okay, so this is basically one must understand. Okay, then you can able to find if it is near field diffraction, source and the screen are nearer, so you don't need any lenses in order to produce the diffraction pattern. So you don't need no need of lenses in order to get the diffraction pattern. Whereas in the case of Fraunhofer diffraction, since the parallel beam of rays are coming from the long distance, in order to get the diffraction pattern, lenses are required. So lenses are required in the case of Fraunhofer diffraction. So these are basic important things one must understand. What is meant by the diffraction and what are the different types of diffractions and how to compare the Fresnel diffraction and also the Fraunhofer diffraction. Okay, so I can revise you once that this Fresnel diffraction is called as a near field diffraction. Why? Because the source and the screen from the obstacle is at near distance, nothing but the finite distance. Okay, whereas in the case of Fraunhofer diffraction, the source and the screen are at far distance. That's why this is far field diffraction, or you say which is source and screen are at the far field, so you can say it is infinite distance, so infinite diffraction. Okay, now the wavefronts are spherical or cylindrical in the case of Fresnel diffraction, whereas in the case of Fraunhofer diffraction the wavefronts are plane wavefronts. Why? Because the wavefront which is coming from the far distance, that gives the plane wavefront. Okay, nothing but the parallel beam of rays, for that the normal is the plane wavefront. Now coming to the next one, which is important, you don't need any lenses in the case of Fresnel diffraction, whereas lenses are required in order to get the diffraction pattern on the screen. Why? Because they are coming from the long distance, so you need a lenses to get the diffraction pattern in the case of a Fraunhofer diffraction. So this is what the overview of the different type of the diffractions.